Hi guys, welcome to my presentation on designing for sustainability and resilience in geotechnical engineering. I chose this topic for my specialization for this semester because I found sustainability very interesting in how fast it is growing across all different types of engineering and other special subjects. To really understand how sustainability works with geotechnical engineering and other engineering, it is important to understand the philosophy and the general definition of what sustainability is. The Brundtland Commission, which was appointed by the UN, defined it as the development that meets the needs of the present without compromising the ability of the future generations to meet their needs. So that's a very broad definition of sustainability, but it helps with a better understanding of how sustainability should embed um, the importance of future generations in the world we have today. To really break it down, though, there's two types of sustainabilities we're going to look at. The first one is weak sustainability, which is the idea that natural capital is replaceable by human capital or technological development if the total capital base remains constant. What this means basically is that the resource sufficiency approach, which is like a anthropocentric view, which means that recognition for biodiversity or moral values are minimal. So basically sustainability is met with the most minimal requirements. Um, and then the opposite of that is strong sustainability, which measures sustainability practice based on the risk of the damage to the reproducing capacity of a self-generating system. And what this basically means is that this is where sustainability becomes the highest priority. So instead of the lowest requirements, it's of the highest. And to really understand sustainability in geotechnics, it's important to understand how big of a role um, geotechnical engineering and engineering in general plays in the world. 40% of global energy consumption is accounted for in the construction industry. So things like large amounts of sand, gravel, stone, which are resources, and large amounts of energy are depleted by the construction industry. It is also extremely challenging position at the beginning of any construction project when environmental and sustainable costs are at the largest value gained, and geotechnical engineering is the first, one of the first, if not the most important um, first part of any project. And majority of the industry right now designed based on budget limitations, previous experiences, and personal perceptions of the engineer on the project. And the problem with that is that there are certain tools out there, but not many of them are being embedded and used within engineering to be sustainable. The biggest difficulty with sustainable engineering currently is that they're difficult to formulate. There are multiple solutions, but they're usually incompatible. Time frames are open-ended, so you never know when the project's going to end. And then the problems are unique. They come out of nowhere sometimes, and they're kind of just hard to solve. And there's many value systems or objectives that compete with each other. So lots of like head to head. Like if you solve one problem, then another one comes up. One of the methods that is currently recommended for designing for an approach towards sustainability in engineering is the method of three E's. The three E's being the environment, economy, and equity. The primary focus is the cost, while environmental impacts and social concerns are the constraints. And the three E's concept is an approach that is multidimensional and can have a positive impact when balanced properly. The proper implementation of this requires to be as close to the middle of the triangle as possible. And if you're leaning towards a certain corner, it can have negative effects. Like if you lean more towards economic growth and environmental, it can cause a conflict of depletion of resources or like an increase in pollution. Also, if you lean more towards the economy and equity, there can be an increase in poverty. So, achieving a good balance of the three E's is important, which sometimes can be easier said than done. So, the method of three E's is a good method, but it is not as efficient as the spear chart, or in this case, we're going to call it the geosphere. Um, the spear chart is an excellent example of a tool that can be used with many different systems because they have over 100 different indicators on the chart that can be kind of customized to each um, aspect of engineering, in this case, geotechnical engineering. To make it more relatable to geotechnical engineering, certain indicators were removed, about 16 of them to be exact. The indicators that were removed were indicators that were more related to global supply chain, service contracts, or operation management tools. And in return, there were indicators added that were more related to quantitative indicators that involve calculations um, or more in-depth analysis that is geotechnical engineering related. This chart is important to use in geotechnical engineering because it has a different scale that can help understand where where more effort or design redesigning needs to be implemented within an infrastructure when analysis is being conducted. All right, so I went over sustainability and the importance of it in engineering. Now I'm going to talk a little bit about resilience, which is slept on often when sustainability is being considered in design. Um, what is resilience? Resilience is the measure of persistence of systems and their ability to absorb change and disturbance and still maintain the same relationship. To put it in simple terms, it's the ability for a system to bounce back. Back in 2005, when Hurricane Katrina hit New Orleans, there was a reported total damage in excess of $100 billion and 1,800 fatalities. This was a natural disaster that happened, and there was a power outage for months, and there was stoppage in petroleum, loss of electricity, so there was no pump stations, and no pipelines working. This is an example of how our limitations and our inability to predict these disasters can have a bad effect on society. And as a matter of fact, it is nearly impossible to design for a perfect system. The best method is to design for something that is resilient as possible. Um, like, for example, if Hurricane Katrina had the infrastructures designed, specifically the geotechnical infrastructures designed for a more resilient infrastructure, many of the problems could have been avoided, like broken piping due to earth pressure, due to collapse of things that were due to landslides or anything that was related to geotechnical engineering. And a proper implementation of resilience would have helped avoid the that many of the disasters, not only in Hurricane Katrina but other disasters as well. So, a little bit more about resilience in actual engineering um, is that there's four main characteristics that are crucial factors that should be taken into consideration, and that is robustness. The robustness is the strength of a system to withstand a given level of stress without the sacrifice of performance and functionality. It reflects in how well a system can absorb the stress that will lower the likelihood that damage occurs in the system. The next characteristic is rapidity, and that is how well a system can bounce back after an event and how it can contain the losses without any further disruption into the system. And rapidity can contribute to the overall recovery with a better performance recovery. The next characteristic is resourcefulness. And that is how well the system can identify issues, establish priorities, and mobilize resources such as money and technology when an issue does occur. And when enough resources are set aside for a system, it can help with the rapidity of the system. So one characteristic usually helps with the other, and they kind of bounce back and forth off of each other. The final characteristic is redundancy. Redundancy is the extent to which existing elements or systems are substitutable. It can reduce the consequences of failure and, in return, the overall system. And redundancy, some might say, is probably the most important one because what it's saying is basically if one part of it fails, does the whole system completely fail or will it still run under partial performance? Resilience can often be looked at as a function of time, and that is because resilience is more of a quantitative characteristic, and it's easier to approach a design or to understand how an infrastructural will act, when a disaster occurs. So as you can see here on this chart, there is resilience based on graphed as a function of time with an equation for R at t that can be used to solve for resilience mathematically. And what this helps is it can help with proper design calculations that will optimize an infrastructure. So being able to look at an infrastructure based on a function of time can help change the perspective from fail safe, and it'll help design based on safe to fail. And this basically goes towards, how can we make sustainability work in contrast with resilience? Because both are very important to be considered for future design by all engineers. Sometimes what happens, especially now that sustainability is such a major topic, is that many engineers are designing for sustainability and they're forgetting about the importance of resilience. So it's crucial that both are considered because when something is resilient, it's most likely going to last longer, which in return is sustainable. So they both play hand in hand. And when both are considered, it can be effective for proper land use, reduction of waste, reduction of materials. It can be efficient energy and it can be used with, it can cause efficiency in energy and carbon reduction. And it's, it's very critical that both are considered hand in hand. So it is evident that the need for sustainable engineering practices and building resilient infrastructures are crucial to sustain a higher quality of life as the health of the planet is slowly deteriorating. The exponential growth of population, unexpected change to the climate, and unacceptable ethical practices from all disciplines are affecting the sustainable growth that is desirable to the biosphere. I hope you guys enjoyed my presentation, and please let me know if you have any questions. Thank you.